In this problem, we're given three equations for reactions, and we're asked to first identify them as being combination types, decomposition, or displacements. Then write a balanced molecular equation for each one, and for B and C, write the total and net ionic equations, and finally to identify the oxidizing agent and reducing agents. Okay. These equations can be balanced by inspection, or in the case of the ones that are redox, which is all of them, you can use the oxidation number method as well. To begin, by inspection, we can see that 8 sulfurs in part A will translate into 8 sulfur tetrafluorides. And 8 sulfur tetrafluorides will contain 4 times 8 or 32 fluorine atoms, which will make 16 F2 molecules. So the balanced equation will be S8 solid plus 16 F2 gas goes to 8 SF4 gas. Now, this is a combination reaction, and we make that assignment because two things combine to form one thing. The number of reactants is greater than the number of products. So it's a combination. The next thing we need to do, after having written the balanced molecular equation, which we've done here, is to identify the oxidizing agent and reducing agent. In order to do that, we'll write the oxidation numbers. I'll write them below the species here. Oxidation number of sulfur in the elemental form S8 is 0. It's also 0 for fluorine in the difluorine state, which is the elemental state. And in SF4, sulfur has a +4 oxidation number, and fluorine has a -1 oxidation number. And therefore, sulfur increases in oxidation number, so it is the reducing agent. And fluorine decreases from 0 to -1, so it's the oxidizing agent. For part B, we have the cesium iodide plus chlorine gives cesium chloride plus iodine. Okay. First, we can balance this. I think it's clear there's going to have to be a minimum of 2 iodines, so we have I2 over here, so we're going to have 2 in front of the cesium iodide. And then Cl2 will leave us 2 cesium chlorides plus I2. So that's the balanced molecular equation, and this is aqueous, cesium iodide's aqueous, and the cesium chloride's aqueous. Now, this is a displacement reaction because two things form two things. You could think of it as chlorine displacing iodine from the cesium iodide compound. Iodine comes out. To write the total ionic equation for this, we would recognize that 2 cesium plus aqueous plus 2I minus aqueous plus Cl2 goes to 2 cesium plus aqueous plus 2Cl minus aqueous plus I2 aqueous. Now notice that the 2 cesiums are the same on the left as on the right. So they are spectator ions, and we eliminate them to form the net ionic equation. The net equation is 2I minus aqueous plus Cl2 aqueous, goes to 2Cl minus aqueous, plus I2 aqueous. That's the net ionic equation. As far as the assignment of oxidizing agent and reducing agent, iodine is -1 in cesium iodide and 0 in diiodine, and so iodine undergoes an increase in oxidation number, so it is the reducing agent. Chlorine is 0, goes to -1 in cesium chloride, so it undergoes a decrease in oxidation number, so it is the oxidizing agent. Now, for example C, we have nickel nitrate. This is nickel in the oxidation state of +2. Plus chromium goes to chromium 3 nitrate. This is +3 here. And nickel solid, which would be 0. Now, chromium displaces nickel from the nitrate compound, so this is a displacement reaction. And to balance it, it will take, there must be 3 nitrates per chromium over here, and the nitrates come 2 at a time, so we're going to have to take 3 nickel nitrates plus 2 chromiums goes to 2 chromium nitrate. There's our 6 nitrates, aqueous, plus 3 nickel solids. So there's the balanced chemical equation. And as far as the total ionic equation goes, we have 3 nickels, 2 plus, aqueous, plus 6 nitrates. 3 times 2 is 6 nitrate ions, aqueous, plus 2 chromiums, solid, goes to 2 chromium 3 plus 6 nitrates, plus 3 nickels. The nitrates are the spectator ions. These are spectator ions because of the same left and right. So the net ionic equation is 3 nickel 2 plus aqueous plus 2 chromium solids goes to 2 chromium 3 plus aqueous plus 3 nickel solid. That's the net ionic equation. Now, the reducing agent and the oxidizing agent is pretty easy to assign. Nickel goes from a +2 state to a 0 state, so it's a decrease, so it's the oxidizing agent. And chromium goes from 0 to +3, that's an increase, so it's the reducing agent.